So, last class we were discussing about inter-process communication. So, whenever two processes communicate each other, both the process can be locally present either in a single computer or in a LAN, not of course in man and one. So, when both the process exist on a single computer or LAN, we call that between two local processes. For that IPC is used, inter-process communication system is used, and whenever you want to communicate remotely, then we use the RPC mechanism. So, RPC is a mechanism to allow the communication between two remote processes. Is it okay? So, these are the two broad way of classifying the inter-process communication into two types. One is the first classification A, that is between local processes or between the remote processes, right. So, there are two types of broadly you can divide. Then for making this inter-process communication effective, we need a sending process environment from where the data will be sent, and we need a receiving process environment where the data will be received, right. So, this sending process environment must be at the client side and the receiving process environment must be at the server side, if it is a client server communication type. Okay. So, to carry out this sending process and receiving process, we use a number of abstractions. What are the abstractions? Send and receive. Send and receive are the abstractions, and these abstractions are implemented in various forms. Like we can implement at the language level or at the libraries level or at different package level, right. What is language level? If any language supports these abstractions in the form of library, that is one way of implementing the send and receive abstractions. For example, C++ or Java. So, they have inbuilt libraries, that is one way of implementing the sending and receiving operation. Another way is that we can take the this library is independent and we can integrate to the language. This will be developed by some different vendors and later they can be integrated with the language. So, this set of libraries, if are available independently, are integrated with the language, that is another way of implementing these abstractions. And why these abstractions are necessary? Because you want to carry out send and receive operation. The client will send some request message and server will reply, right. So, send and receive, they are the basic task needed, that is what we call the abstractions. And third way is that we can altogether will have a different package. So, there are the various ways to implement these send and receive abstractions. So, we have to see which languages supports this or which packages supports this. There are number of packages, standard packages are available in the society, and a number of languages are also supporting this, like C++, Java, they support directly, and different packages which are already available in the form of tools which are used in the industry. Those in the industrial applications. So, these primitives are available in the form of tools. Directly you can use the tool and carry out the inter-process communication, right. So, these are the implementation forms. We are not worried about the implementation forms. We are more worried about the what should be the sending process environment and what should be the role of language, what should be the role of operating system and what is the role of hardware. So, these are very important for us, because this send and receive operations are to be executed on a machine to carry out the send and receive operation. And these abstractions should be at very high level or it can be also low level. Low level means you have to specify what kind of protocol you should use for communication, right. So, this is the primary task, that we should have set of abstractions for supporting the inter-process communication, that is the first one. Second is that we need a communication medium, which you in the abstraction form we can say it is a channel. Channel need not be physical. Whatever we have studied in computer network or data communication, channels refers to a communication medium, that is hardware. A wire is a communication medium, wireless is a communication medium. But here we are talking about the abstraction. We should name those channels, we should name those hardware devices, and we should use some kind of names that will indicate they are the real entities without worrying about the physical entities. So, that is called naming. So, whether it is a channel or any process or anything you are using in a distributed system must be given a name, and that naming scheme should be such that whenever I access a particular channel, I will be referring to that physical channel, right. So, this set of abstractions usually are implemented at the top of network layer. If you recall the OSI reference model, we have the physical layer, then we have data link layer, we have network layer, we have a transport layer. So, these three, on the top of these three layers, we implement this set of abstractions, mostly from transport layer to application layer, and we are free to implement at any layer, because there are many protocols like TCP and UDP IP. So, transport layer, presentation layer and application layer, they refer to a single layer. So, layering is done for the simplicity, for modularity, so that we can independently develop the modules, but in reality there can be protocol which can implement everything if a distributed system is a small system. If it is a small system, we can implement all these layer functions into a single module, there is no problem, like your LAN. Am I clear? So, why we are using these abstractions? To make the programmer flexible. So, programmer only use the abstractions and carry out all the inter-process communication. That is the goal of this inter-process communication. Then this is the first and foremost requirement. We should have a set of abstraction that should refer the sending environment, receiving environment and communication channel. Because in order to establish a communication, we need three entities. One is sending environment, other is receiving environment, and third is the communication channel which will be used for communication. Okay? But they may not be available in the form of physical, that is our goal. It should be available in a virtual form or logical form in the form of abstractions. And those abstractions can be supported by the language directly, or can be supported by set of libraries integrated into language, or set of libraries available in the form of package or tool which can be used by the programmer, whatever the nowadays the industry people do. But if you are going to develop a protocol, I think that you cannot use the tool, you have to go for the libraries or language level. But if you are developing some kind of applications on the top of distributed system, I think this is sufficient. You should use the direct package, because we will not be worried about how to implement the sending and receiving operations. Am I clear? So, these are three entities essential. One is sending environment, second is receiving environment, and third is the communication channel. And this must be available in the form of abstractions by using a naming scheme. Naming scheme means we should associate some kind of identifiers, names to these entities. Am I clear? So, whenever we implement these abstractions, for send operation I can use also S, for receive operation I can use R, I can give any name, right. So, it depends upon the syntax of a particular language or particular package, clear. So, apart from these three entities, there is one more thing is also required. What is the second thing? That a synchronization between sending and receiving activity. Why the synchronization is necessary? Because as I told you, computer is a machine. A distributed system is a collection of small machines. The way we program, it will be performing. It is not a human being. So, synchronization is necessary. Why? Because after sending the message may not reach at the destination. So, what you have to do? You have to resend it. But how the receiver will know that the message is not sent? And if you want to resend, after what time you will resend it? Right. So, that means whenever we send a message, that message should be stored temporarily, assuming that in future time it will be resent again. You have to store that message temporarily in a buffer, and in case that message is lost on the way or during the operation, the same message can be again resent. Am I clear? So, for that we need buffering, and buffer size should be also defined. If you have a small buffer, what will happen? It cannot accommodate more messages, and if you have a more number of buffers, there can be buffer underutilized. And where you will get these buffers? So, these buffers are also abstraction. Remember, in a distributed system everything is abstraction, but physically its meaning will be something different. So, buffers physically I can assume a set of memory locations from the RAM can serve as a buffer, but while using in the programming language I can give a name buffer. So, this is an abstraction over the set of memory location. So, set of memory location will be occupied by this buffer, and this buffer I can use in my program to indicate that these are the messages to be stored there. Or you can understand that buffer is referring to a set of memory location where the messages are stored. The only thing is that you have to locate that particular location where these messages are stored. That is the task of an operating system. So, instead of telling it is a task of operating system, I will tell it a task of a process or a service, and that process can be implemented in the form of kernel, inside the kernel, or I can implement at the top level as a user process. Because in a distributed system everything is open, you need not be worried about the set of services which are provided by the kernel. Rather, the user processes can do many things as compared to kernel processes. Right. So, I think we understood what is the meaning of abstraction. Abstraction is the set of names should be used by the programmer which will be referring to the physical entities, but virtually it will be doing the task. That is what we mean the buffering. Buffering is also an abstraction, send is abstraction, receive is abstraction, channels are abstractions. Everything is set of abstractions or simply set of names. Right. So, for everything we need a name. So, therefore, naming is very, very important in a distributed system, and your naming scheme should be efficient, so that the interprocess communication will be efficient. And if at all you are using any protocol also, it should be given a name. Everything should be given a name or identification. Right. So, now if I see the synchronization, there can be two types of communication. Again we divide the communication into two types. One is synchronous, another is asynchronous. So, do not confuse, in the communication can be broadly divided into two types based upon the locality of communication between local processes or between remote processes. Now, communication can be divided into again further two types, one is called synchronous, another is called asynchronous. What is synchronous? That after sending a message, the sender will wait. Before sending or before sending the next messages, sender must wait for the acknowledgement for the first messages, that is called synchronous. And asynchronous means without waiting it will keeps on sending, which is not reliable, is not it? Asynchronous is not reliable, but what is the advantage of asynchronous communication? There is no requirement of buffer, because we are not going to store the data further. So, these are the various forms. So, whenever cost is important, we should go for asynchronous. When the cost is not important, we should go for synchronous. So, we shall see which operating system, which platform uses synchronous type and which are using the asynchronous type. Or we can say synchronous is also called blocking type, blocking, because it will block the message, wait for the other messages, but asynchronous is called non-blocking. There are two types, one is blocking, non-blocking, they are the other names. Synchronous means blocking, asynchronous means non-blocking. So, as I told you, the abstractions for sending environment we use send, for receiving environment we use receive. Similarly, abstractions for channels we will use channel. Channel is itself a name also. Some platforms and operating system uses the channel as the identifier or a name for communication. Or we can use socket. I think in the laboratory class we have already used socket. Socket is also an abstraction, and this is used by Unix, right. Similarly, I will tell which operating system uses channel, which uses sockets, and you can also use ports. Ports means not physical ports, some name will be given and that name will refer to the physical ports. So, they are the virtual ports. So, some operating system allows the communication between two processes using ports. Some allow sockets, some allow channels, some allows ports. So, these are the typical examples for the synchronous or asynchronous communication. So, synchronous means blocking and asynchronous means non-blocking. Blocking means it will block the message before sending the next message. That is what we understand the blocking. So, communication type can be synchronous or can be asynchronous. So, synchronous can be blocking send or blocking receive. So, in the synchronous communication both sender and receiver are blocked. You can see yes, yes. That means before sending the next message, the sender will wait, and before receiving the message, the receiver will wait in the synchronous communication. So both are blocking, both will be waiting. So what it means that both sender and receiver have to maintain the buffers. Whatever blocking comes to picture, we need a buffer, isn't it? So sender has to maintain a buffer, other without buffer it cannot wait. So receiver also has to have a buffer. So two buffers are required for the synchronous communication. And what is the language? OCAM. I think I have told you OCAM is a language used in the supercomputers. And though supercomputer is not a full-fledged distributed system, but it can be a distributed system also. Okay. So based upon the shared memory concept, as I told you, there are two types of distributed system. One is shared memory, another is message passing. So supercomputer is a shared memory kind of distributed system, and which uses the language OCAM, and OCAM language supports this synchronous communication. That means if at all you use the abstraction send and receive, this will allow the synchronous communication. Am I clear? But the communication will be costly. And for a supercomputer, since it is meant for only single application, for weather forecasting or business forecasting, then it may not be costly, because only once it designed, it will be used forever. But for a general purpose distributed system, synchronous is not always advisable. Rather, we should go for the asynchronous. So what is asynchronous? Asynchronous means there is no buffer. Usually the true asynchronous, where sender side there is no buffer, receiver side there is no buffer. So there is no way of storing the data. So as and when the data ready, it has to be sent, and as and when the data is ready, it has to receive. So therefore these are the most unreliable, you can say. The most unreliable communication is asynchronous, where both sender and receivers are not blocking or not waiting for the data to be transmitted. Clear? So the kind of language or system which uses this Charlotte. So these are the standard available in the society for the communication primitives or communication, interprocess communication. Is it okay? So still there is another form of asynchronous, or we can say broadly we can divide the communication into synchronous and asynchronous, and asynchronous can be further divided into two types, where both blocking and both sender and receivers can be blocked, can be having buffers, but here without having buffers, and here in asynchronous the blocking send and no. What is the meaning? There is no buffer in the sender side, however there is a buffer in the receiver side. So this you can say a special kind of communication, that is not a true asynchronous. Asynchronous means there should not be any buffer, there should not be any waiting, but has still divided into two types. Okay. So here blocking send no, but blocking receive is yes, and the kind of distributed operating system which supports this is Mac, Chorus and BST 4.x Unix. That is the upgraded or the latest version of Unix. So Unix has two versions. One is only for the mini computers, where the computer systems will be treated as the terminals, right? And we can have a distributed system where the Unix can be used for interprocess communication, right? So that is called BST 4.x Unix. I think this was developed at MIT. Even Unix was also developed at MIT long back, but for when the distributed systems came to market, this was also developed and improved by the MIT, Massachusetts Institute of Technology, USA. So anyway, if you are using a blocking receive or a synchronous kind of communication, where we should have the buffer at both sides, at the sender side and receiver side, and before sending the next message, how long will you wait? Because synchronous means blocking means you have to wait, but how long will you wait, and how to find this waiting period? So usually many systems they implement a timeout mechanism. Based upon a particular estimation, they find a timeout value. After this particular timeout value, let us take threshold theta, again the same message will be resent. But predicting this theta value depends upon the environment and network topology, architecture, etc. Right. So, this is itself a problem, how to predict the threshold value for a timeout before blocking or before sending the next message. Right. So, this is a very, very important point. If time permits, we shall see how to estimate the timeout for a distributed system before sending the future messages. Right. So, this is how the communication takes place between two processes in a distributed system, whether it is a LAN, MAN or one kind of distributed system. So, okay. So, again most important thing for inter-process communication is message destination. So, you have to define the message destination where the message will be sent from the sender to receiver. As I told you, there are various abstractions available as the message destination. One is processes, again it is followed by the operating system V. V is also one kind of operating system, which is a distributed operating system which supports the message destination processes. Directly process can send the data to message to another processes, and every process must be given a name, and here location independent. So, what is location independent? So, whenever you send a message in internet, what we need? We need an internet address, that is IP address, and we need a specific port number. So, this knowing this IP number and port ID directly is not location independent, right. If it is known indirectly by using a naming scheme, only we can mention the name, and it is the task of a distributed operating system which will convert this name to the IP address and its ports. Then this name will be location independent. Did you understand the difference? That whenever you send a message, that message must be destined to a particular location, and if the location is known, it is not location independent. And if the location is given a name, and if we access that name for getting that location, for identifying that location, we call it is location independent, right. So, you might have already used the socket system call. Here you can see that explicitly you have to mention the kind of protocol, network, everything in the form of arguments in the socket system call. So, therefore, it is not location independent, because manually the user, the programmer has to mention the IP address, port address, everything. But if you give only the names, that is enough, right. So, that is why we call location independent. So, if we use the process concept, ports concept or objects concept, if the message destination is available in the form of processes, ports or objects, we call it as location independent. Am I clear? So, the kind of abstraction ports used by MAC, Chorus and Amoeba, which are the standard distributed operating systems used in various distributed environment, right, and it supports location independent identifier. Similarly, groups of processes, instead of using a single process, you can send a message to another group of processes directly using a single primitive by using the multicast communication. Again, communication can be divided into two types depending upon the volume of communication. We can use unicast, multicast, of course three types also you can also divide into three types, broadcast, but broadcast is not a preferable solution for a distributed system. But for a network, broadcast communication can be useful. For a distributed system, it is unicast and multicast. So, unicast means what? One process is communicating with the one process. In multicast means one process communicates with a group of processes, and that group of processes will have a single primitive defined by the languages or the systems. Am I clear? And a multicast service can be implemented using the unicast services, right. Suppose a language or platform does not support multicast, but you want to implement a multicast. So, you can define your old multicast protocol by using successive a number of unicast communications, because after all multicast is nothing but set of unicasts, but there are many languages and platforms that directly support the multicast communication in the form of group of processes. So, the message destination can be group of processes or the message destination can be group of ports, and in all these cases except the socket system call, all support the location independent message destination, right. But only the socket system call, which is extensively used by the Unix operating system, of course the BSD version of Unix operating system uses the socket system call or facilitates the socket system call for inter-process communication between two processes, right. Now, we shall see how a socket system call is useful for communication. So, this system call I think you have already used in the laboratory for inter-process communication, is not it? Along with the socket system call, you have also used these system calls: bind, listen, accept, etc. Right? In the socket system call, you might have seen 3 arguments or 3 parameters used within the brackets. Within this parenthesis, we are using 3 arguments, and each argument has its own functionality or name. Like the first one gives you the domain name, second one gives the type of communication, whether it is datagram or stream. Stream means connection oriented, the connection must be established and the communication can take place, data can be sent, that transfer can start. And datagram means connectionless, you can send the data in the form of packets. So, here you are in the stream communication, we send several bytes of data, right, but here we send several packets. So, connectionless, and this indicates a protocol name, and if you write 0 here, by default it is TCP/IP. TCP/IP means connection oriented and UDP/IP means connection less, right. What is the advantage of connection oriented? That until the communication is completed, the connection cannot be terminated, but in a connectionless, it can be in offline mode. The data, the messages can be transferred or the packets can be transferred. The packets of same message can follow different routes while communication, but in TCP/IP it has to follow the same route because connection oriented. Am I clear? So, these are the various system calls we use for establishing the inter-process communication, but only demerit is that in a socket system call it is not location independent. So, since it is location independent, this is good for communication between local processes, but whenever you want to communicate between remote processes, then the socket system call may not be useful. For that you have used a bind system call, where the socket must be binded to a name, to a server address, then only the communication is possible, and that is you shall see in the inter-process communication in the form of RPC, that is remote procedure calling, how it uses the binding service to assign a server address to the socket system call, and the socket system call whenever it is executed, it will return a file descriptor. By using that file descriptor and the server address, we can send the information to the receiver side. Am I clear? So, these things already we are implementing in the laboratory, but we have to see what are the parameters we use and what is the significance of each and every parameter for all the system calls, not only socket, for bind, listen, accept, and a few are necessary also. And another important thing is that for a remote procedure call, when you send the messages, as I told you, the messages which are available in the sending environment may not be compatible or suitable for intermediate nodes in the distributed system. Therefore, it must be represented externally by using an external representation format, right, and which has been standardized by different languages and various standardizing bodies, that we shall see in the next class how to represent the XTR, that is the need of marshalling and non-marshalling. What is marshalling? It has to change the data structure which are used in the program is to be converted to a form suitable for the intermediate nodes in a distributed system. Is it okay? So, that means every time if you see in a distributed system, we are depending upon set of abstractions, either they are available in the languages directly, or they are available as the operating system library routines, or they can be available a separate set of library routines in a package. Somewhere it should be available, but the kind of abstraction is very much important for us, right, and this abstractions will be provided by a naming scheme. For example, these domain names which are defined in the socket system call .com, .gov, .in, like NIT Rourkela.ac.in, that is a domain name, and that domain name must be used for communicating the data in the form of stream communication or in the form of datagram communication using a particular protocol, either TCP/IP or UDP/IP over the network. And these socket system calls are implemented at the transport layer, that is top of the networking layer, right. So, first physical layer, data link layer, network layer, and network layer onwards these system calls are implemented in the form of either in the operating system or language or can be a package. There are three ways to implement this, right, and which one is better, that is also a case. That is, if you want to implement an operating system, what is its advantage and disadvantages? If you want to implement at the language level directly, or it can be implemented at the package level. So, which is preferable? If everything is implemented at the operating system, we call it as a monolithic operating system, because you have to implement everything in the inside the operating system and the kernel size will be bigger, right. And if you are implementing at the package level, then kernel size will be smaller and everything will be available in the form of user services or user processes, which is most efficient one. But at the same time, the the demerit is that security. If you make everything open, then security is a problem, right. So, all these issues we shall discuss when we will go to the design of distributed operating system based upon this process and abstraction concept. Okay. So, if you could understand what is abstraction of a different sending environment, receiving environment, channels and other concepts of distributed system, I think we will be able to understand what is a distributed operating system, right. Because after design of distributed operating system, whatever the issues will come, like election, how to elect a process, suppose several processes are there, how to elect one process, or how to synchronize the different processes, how to tolerate a fault in the processes, and how to maintain concurrency, how to maintain agreement, how to maintain consensus. All these are the set of services available in a distributed system. But underlying of these functions, there is a what you call operating system and a network. And this operating system and a network, they are available in an independent form. We shall use set of abstractions to make this operating system and hardware, networking hardware functional by introducing a set of abstractions. Am I clear? So, the concept of abstraction is very important in a distributed system, because we don't go the details of the networking, how the network protocol works, that is not our task, but for every protocol there must be a name, and only we have to use that name for communication or for achieving a task. Am I clear? So, you do not misunderstand with your networking subject or operating system. We are not going to discuss the operating system here or network here, but the fundamental concepts of operating system and networks are necessary for understanding this subject. Am I clear? So, once you understand the remote procedure calling and distributed operating system design, I think we can easily cover the remaining portion of the syllabus, like election, consensus, agreement, fault tolerance and concurrency. And of course, that is one more important thing is scheduling and load balancing. So, the course is very how do you call, volume is very high, but we have to finish up based upon the fundamental concepts. So, once the fundamental concepts are clear, then I think we can cover the rest of the syllabus very easily and fastly also. Okay. So, this is very important. So, if I have already used the socket system for inter-process communication, try to use the socket system call for remote procedure calling also, assuming that both the processes are available at a remote place or the distance between two processes are very high. And if at all is necessary, you change the data structures or the concepts which are used in your sender side to a form, that is what we call the marshalling. So, try to implement each and every concept of distributed system, because you will not get an opportunity to implement this In the industrial applications, they directly use the tools and packages, and how the marshalling is done internally we are not caring. But here in this subject we will be able to implement each and every concept of the distributed operating system or distributed systems. So, then next, finally, we shall see what are the different implementation mechanism for the interprocess communication. Implementation of interprocess communication. What are the different forms which are available in the standard form in the literature? So, one is called pipe, which we have already studied in operating system using the pipe system call, and another is FIFO, or directly you can use message for communication, or you can use message queue, or you can use semaphore for communication, or you can use shared memory, which is not usually preferable because this does not support the distributed system concepts, shared memory, right. But you can use the virtual shared memory. That means many portions of the many contents of the every nodes in a distributed system can be combined together to define a single memory, which is an abstraction over the physical memory in a distributed system. Am I clear? So, you can take out some portions of the memory from a node in distributed system and unite all the portions of the different nodes from the distributed system and make it a single one, which is a virtual one, not the physical one. Physically, we can take a portion of each memory, and that virtual memory can be used as a shared memory for communication. Then we can say it is a shared memory. Otherwise, if we are trying to share the physical memory for communication, this cannot be a distributed system in our terminology, in our definition. Am I clear? So, do not confuse with the shared memory, rather it is a virtual shared memory, and physically it spans the memory of number of nodes in a distributed system. And finally, we can also have another form of communication for implementation, signals. Mostly it is used every time you have to generate an interrupt, like if you press Ctrl C, Ctrl P for printing. So, all these are the signals in the command prompt. This is how also you can communicate with the computer and two processes by using the signals. So, this pipe and FIFO signals, so the semaphores, shared memory, so these are all useful for the local process communication in the IPC. But for RPC, we have to use message queue, etc., and the concept of processes, ports, etc. So, these are the set of abstraction we should use for the RPC, that is remote procedure calling. But once you are using RPC, there will be lot of heterogeneity, because two processes are available at the remote side and several nodes are coming in between. So, for that you have to depend upon XDR, that is external data representation. Again, it can be directly supported by the language or can be supported by some standardization organizations like Sun Systems. We call Sun RPC, is a very popular standard available. So, this is this standard says how to represent your data or messages in a form so that it can be suitable across the distributed system. Am I clear? So, we shall see how the RPC mechanism is used for allowing the communication using the message and message queue abstraction. So, pipes and FIFO, they are not preferable for the RPC, but they can be preferable for interprocess communication between two local processes in the same computer and mostly in the LAN, right. So, if you have studied in operating system pipe and FIFO, you can implement in a laboratory, but they are not the true form of communication abstraction for communication in a distributed system. Am I clear? So, this is how we finish up IPC, then we shall go for RPC, then we shall go for distributed operating system.